Hello dear students. In this session we are going to discuss about the laws of thermodynamics. There are 4 laws in thermodynamics: zeroth law, first law, second law and third laws. In this particular session we are going to discuss about zeroth law of thermodynamics and then first law of thermodynamics. This zeroth law of thermodynamics is related to the temperature concept. Actually, this law came into existence after the first law and second law of thermodynamics, but it is a very fundamental law of all the other laws of thermodynamics, hence it's named as zeroth law of thermodynamics. Now let's see the statement of this zeroth law of thermodynamics. The statement is, if the system A is in thermal equilibrium with the system C and if the system B is in thermal equilibrium with the system C, then system A and B will be in thermal equilibrium with each other. I'll repeat the statement. If system A and C are in thermal equilibrium with each other and system B and C are in thermal equilibrium with each other, then automatically system A and B will be in thermal equilibrium with each other. Here, what is thermal equilibrium? We have discussed that in our previous session, right? What is thermal equilibrium? Thermal equilibrium means the temperature remains constant. Here, the system A and C are in thermal equilibrium with each other means the temperature of the system A is equal to the temperature of the system C. Both have same temperature. Here, the system B and C are in thermal equilibrium with each other means temperature of the system B is equal to temperature of the system C. Then the system A and system B will also have the equal temperature, same temperature. This is similar to the transitive property in mathematics. In mathematics, you heard about transitive property, right? What is transitive property? If A is equal to C and B is equal to C, then automatically A is equal to B. This is called transitive property in mathematics. This statement of zeroth law of thermodynamics is similar to the transitive property in mathematics. I'll repeat the statement. If the system A is in thermal equilibrium with system C and system B is in thermal equilibrium with system C, then automatically system A and B are in thermal equilibrium with each other. This is the zeroth law of thermodynamics. Now let's move on to the first law of thermodynamics. First law of thermodynamics. It is also called as law of conservation of energy. Law of conservation of energy. The statement is very simple. Energy can neither be created nor be destroyed, but it can be converted from one form to another form. That is the statement of first law of thermodynamics. The mathematical form of first law of thermodynamics is delta U is equal to Q plus W. Delta U means change in internal energy. Change in internal energy. Q means heat. W means work. The statement of first law of thermodynamics is energy can neither be created nor be destroyed, but it can be converted from one form to another form. The mathematical form is delta U is equal to Q plus W. In previous session, while discussing about the change in internal energy, I have told you that internal energy of the system can be changed in 3 ways. What are those? First one is through heat change. That means by adding heat to the system or by removing heat from the system. The second way is through work done. Either work done by the system or work done on the system. And third way is by adding or removing matter from the system. Among these 3 ways, the first 2 ways, through heat and work, they are common ways, most common ways to change the internal energy of the system. If the internal energy of the system changes only because of heat change, then we can write delta U is equal to Q. That means whatever the amount of internal energy changing in the system will be equal to the amount of it added to the system or amount of it removed from the system. If internal energy of the system changes only because of work, then we can write delta U is equal to W. That means whatever the amount of internal energy is changing in the system, that will be equal to amount of work done by the system or amount of work done on the system. If internal energy of the system changes because of both heat and work, then we can write delta U is equal to Q plus W. Here, change in internal energy of the system is equal to amount of heat added to the system or removed from the system and amount of work done on the system or by the system. Okay. Here, change in internal energy means it might be increasing or decreasing. Internal energy increase ಆದರೂ ಆಗಬಹುದು, ಡಿಕ್ರೀಸ್ ಆದರೂ ಆಗಬಹುದು. ಚೇಂಜ್ ಇನ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಅಂತ ಹೇಳಿದ್ರೆ, ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ ಅಂತಂದ್ರೆ ಅದರ ಅರ್ಥ ಅದು ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ ಹೀಟ್ ಅಂಡ್ ವರ್ಕ್ ಖರ್ಚಾಗ್ತದೆ ಅಂತ. ಅಥವಾ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ ಅಂದ್ರೆ ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ ಹೀಟ್ ಅಂಡ್ ವರ್ಕ್ ಎನರ್ಜಿ ಆಡ್ ಅಪ್ ಆಗ್ತಿದೆ ಅಂತ ಅರ್ಥ. ಅಂದ್ರೆ ಒಂದು ಫಾರ್ಮ್ ಇಂದ ಇನ್ನೊಂದು ಫಾರ್ಮ್ ಗೆ ಕನ್ವರ್ಟ್ ಆಗ್ತಿದೆ. ಸ್ಟೇಟ್ಮೆಂಟ್ ಅದೇ ತಾನೆ. Statement ಏನು, energy can neither be created nor be destroyed but can be converted from one form to another form. Here also the energy is converting from one form to another form. That's it. So this is about the first law of thermodynamics. Now let's move on to the another important concept in this chapter, that is enthalpy. Enthalpy. Enthalpy means heat content of the system at constant pressure. Heat content of the system. Heat content of the system at constant pressure. Whatever the amount of heat present in the system at constant pressure is called enthalpy of that system. And enthalpy is represented by the symbol capital H. Enthalpy is represented by the symbol capital H. And now from the first law of thermodynamics we have this equation, delta U is equal to Q plus W. Here both Q and W are positive. They have positive sign, right? We have discussed about the sign convention of heat and work in our previous sessions. That means whenever we have to take positive for Q and W, whenever we have to take negative for Q and W, that I have told you. Whenever we have to take positive for Q, when heat is absorbed by the system, then we have to take positive. When the heat evolves from the system, then we have to take negative. And for W, when work is done on the system, it should be negative. It should be positive. And when work is done by the system, it should be negative. Right? Here, both are positive. Means heat is absorbed by the system and work is done on the system. If work is done by the system, then we can write the same equation as delta U Q minus W. Both equations are same. Both are the mathematical forms of first law only. Only difference is the sign convention. This is work done by this, work done on the system, and this is work done by the system. Okay. Now let's rearrange this equation. Send this down onto this side. Then we'll get Q is equal to delta U plus W. Here W means work done. In thermodynamics, generally W is equal to P into V, pressure into volume. How we got this? You know that work is equal to force into displacement. Force into displacement, right? In physics, you have studied this. And pressure is equal to force divided by area. Force per unit area is called pressure. Now, force is equal to, cross multiply this, pressure into area. Substitute this pressure into area in the place of force. What will get? W is equal to pressure into area into displacement. Here area into displacement is nothing but volume. So pressure into volume. W is equal to pressure into volume. Okay. ಇದೆಲ್ಲ ನಿಮಗೆ ಬೇಕಾಗಿಲ್ಲ. ಹೇಗೆ ಬಂತು W is equal to P into V ಅನ್ನೋದು ಹೇಗೆ ತಗೊಂಡ್ವಿ ಅನ್ನೋದಕ್ಕೆ ನಾನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದೆ. You need not to remember all these things. Okay. Now substitute PV in the place of W. Q is equal to delta U plus PV. Now let's consider here what is Q? Heat. Delta U means change in internal energy, P means pressure, V means volume. Now let's consider change in heat at constant pressure. Let's consider change in heat at constant pressure. Whenever we mention change in front of any quantity, that means we have to take delta in front of that quantity. Okay. Here heat is represented by Q. Change in heat is represented by delta Q. Internal energy is represented by U. Change in internal energy is represented by delta U. So change in means, that means we have to take delta in front of that quantity. What is now let's consider change in heat at constant pressure. That means delta Q is equal to delta U plus P into delta V. I have put delta in front of all the terms, but before P I didn't put delta. In front of P I didn't put delta. Why? That's because we clearly mentioned here at constant pressure. Constant pressure means pressure should be fixed. It should not vary. Hence, we didn't put delta in front of P. If we put delta in front of P, that means pressure is also changing. But here, we clearly mentioned that at constant pressure. So, we should not put delta in front of P. I hope you understood this. Now, see, what is this delta Q? That means change in heat at constant pressure, right? Here, this is nothing but, this term is nothing but change in heat at constant pressure. Heat at constant pressure is nothing but enthalpy, right? So, heat at constant pressure is nothing but enthalpy. We can replace this by delta H. Heat at constant pressure is nothing but enthalpy. Here, what is this? This symbol is nothing but heat at constant pressure. Change in heat at constant pressure. Hence, this can be replaced by delta H, change in enthalpy. That equal to delta U plus P delta P. This is one of the important equations in thermodynamics, the equation of enthalpy. This tells us the relationship between change in enthalpy and change in internal energy. Okay, this is one of the important equations in thermodynamics. This is very helpful while solving numericals. Okay, now this delta H, here you need not to remember the derivation. Okay, ಇದು ಹೇಗೆ ಬಂತು equation ಹೇಗೆ ಬಂತು ಹೇಗೆಲ್ಲ derive ಮಾಡಿದ್ವಿ ಅದನ್ನೆಲ್ಲ ನೆನಪಿಟ್ಕೊಳ್ಳೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. What you have to remember is this equation. This equation is important, not the derivation. Derivation at all is not included. Okay. Now, delta H is positive for endothermic reactions. For endothermic reactions. What are endothermic reactions? The reactions in which heat is given. It is given to the system. They are called endothermic reactions. For that, delta H is positive and delta H is negative for exothermic reactions. Exothermic reactions means the heat is evolved from the system. During the reaction, the heat is liberated. For those reactions, delta H is negative, is taken as negative. Okay. Now, let's consider the same equation at constant volume. At constant volume condition. At constant volume. At constant volume, delta V is equal to 0. Why? Constant volume means volume is fixed. It's not going to change. Hence, change in volume will be 0. Then, this equation will become delta H is equal to delta U plus P into 0. That means 0 only. So, delta H is equal to delta U. At constant volume condition, the enthalpy equation will become like this. Delta H is equal to delta U. And this is applicable for solid and liquid systems. Solid and liquid systems. Why? Because The solid and liquid systems do not show considerable change in volume upon heating. When we heat solid or liquid systems, any solid or liquid systems, there is no much change in volume. The change in volume is negligible. Hence, we can take delta V almost equal to 0. Therefore, the equation will become delta H is equal to delta U. But in the case of gaseous system, this is not the case. There, if you consider any gaseous system, upon heating, there will be a change in volume. That is considerable change in volume. Hence, delta V cannot be equal to 0 for any gaseous system. And for gaseous system, this equation holds good. Okay, this is particularly applicable for gaseous systems, and for solid or liquid system, this equation is applicable. Okay. Now, let's consider the ideal equation. You know about ideal equation, right? PV is equal to nRT. This is the ideal gas equation. You are going to study about this ideal gas equation in detail in the chapter states of matter again. Okay. Here, the PV is equal to nRT is the ideal gas. P into delta V is equal to delta nRT. Here, delta N means change in number of moles. R means universal gas constant. T means temperature. Here, I can substitute this delta nRT in the place of P delta V in this equation. I will get delta H is equal to delta U plus delta nRT. This is another equation for enthalpy. Okay, this is in terms of pressure and volume. This is in terms of number of moles, universal gas constant, and temperature. These two equations are important equations. While solving numericals, you are going to use these equations, and from the point of CET and NEET also, these equations are very much important. Here, how can we calculate this delta N in a given reaction? Delta N is equal to NP minus NR. Actually, this equation applicable for gaseous systems, right? Gaseous system. This is ideal gas equation, right? Hence, here we put G, subscript G. That means for gaseous reactants and products, it's applicable. Here, NP means number of moles of gaseous product. NR means number of moles of gaseous reactants. In a given reaction, the difference between number of moles of gaseous product and number of moles of gaseous reactants will give the value of delta N. Okay. So this is all about the enthalpy concept. Now let's solve some numericals based on the mathematical form of first law of thermodynamics and the equation of enthalpy. Okay. Now let's solve this problem. Okay. First, I'll read out the problem. A chemical reaction occurs in such a way that 900 joule heat is evolved, and at the same time 150 joule of work is done by the chemical system on the surrounding. Calculate the change in internal energy. What they have given, the data what they have provided, they provided that 900 joule of heat is evolving. That means heat is represented by Q. Heat is evolving means what sign we have to take? Positive or negative? Negative, right? Yes. Minus 900 joule. Okay. Here they clearly mention the heat is evolved. If they mention heat is evolved, we have to take negative sign. Okay. Now work. 150 joule of work is done by the system on the surrounding. Here work is represented by W. They mention 150 joule. Here the work is done by the system. If work is done by the system, then what sign we have to take? Positive or negative? Positive or negative? Negative. Remember the sign conventions for heat and work. If heat is evolved by the system, then we have to take negative. If heat is absorbed by the system, we have to take positive for Q. And for work done, if work done by the system, then we have to take negative for the W value. Or if work is done on the system, then we have to take positive. Here they mention the work is done by the system. Hence we took negative sign. And what they ask us to calculate? Change in internal energy, delta U. Simple. We know that delta U is equal to Q plus W from the first law of thermodynamics. right? So substitute the values in this equation. Delta U is equal to minus 900 plus W value minus 150, minus 150, minus 900 minus 150, minus 1050 joule. Delta U. Okay. They provided heat and work and asked us to calculate delta U. Then we have to use this formula and do the problem. But here what you have to concentrate on is the sign conventions. Now let's discuss about another problem. I'll read out this problem. The enthalpy change for the reaction is minus 92.4 kilojoule at 300 Kelvin. Calculate change in internal energy at the same temperature. What they have provided? Enthalpy change, that is delta H minus 92.4 kilojoule. What they ask us to calculate? Change in internal energy, that is delta U. We have to calculate delta U. And they have provided the value of temperature, that is 300 Kelvin, and R value. Now to calculate delta H value, change in enthalpy value, we have two equations. Delta H is equal to delta U plus P delta V, or delta H is equal to delta U plus delta N RT. Which equation we have to use here? We cannot use this equation. Why? Because they didn't mention anything about pressure and volume in the problem, right? Yes. Hence we have to go for this equation. That is delta H is equal to delta U plus delta N RT. Here they have given delta H value, R value, T value. We have to calculate delta N value by using this equation. They have provided this equation, right? By using this equation, we have to calculate delta N value. Delta N antandre change in number of moles. Then ಹೇಗೆ calculate ಮಾಡೋದು ನಾನು last class ಇದನ್ನ explain ಮಾಡುವಾಗ ಹೇಳಿದ್ದೆ. Delta N is equal to NP minus NR. Number of moles of gaseous product minus number of moles of gaseous reactants. ಈ equation ಅಲ್ಲಿ gaseous product ಎಷ್ಟಿದೆ? 2 moles ಇದೆ. ಇಲ್ಲಿ gaseous ಅಂತ ಹೇಳಿ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ G ಅಂತ ಹೇಳಿ. So 2 moles minus number of moles of gaseous reactants. Gaseous reactants ಎಷ್ಟಿದೆ? ಇದು ಕೂಡ gaseous reactant, ಇದು ಕೂಡ gaseous reactant. 3 moles plus 1 mole. 3 plus 1 4 minus 2. So delta N value is ಬಂತು minus 2. Now substitute all the values in this equation. First, what we have to calculate delta U, right? Take that term to other side. Delta U is equal to delta H minus delta N RT. Now substitute the values of all these terms. Delta H value is minus 92.4 kilojoule. Here it is in kilojoule. We have to convert this into joule. Okay, we have to convert this into joule because R value here, R value in R value, it is in joule, right? So we have to convert this into joule. How much we'll get? Minus 92,400 joule. Substitute that value. Minus 92,400 minus delta N value is minus 2 into R value is 8.314 into temperature is 300 Kelvin. Now if you simplify this, minus 92,400 minus of here, it will come minus 4,988.4 joule. Final answer will be minus 8,007.6 joule. Here, delta H is equal to delta U plus delta nRT. We have taken this equation and substituted all the values and simplified. Then we got delta U value. The unit of delta U, change in internal energy, is joule. Okay, I hope you understood this.